You know the drill. You're building an AI agent in n8n, and to see does it work, you throw lots of different questions at it. And if the agent isn't doing what you want, you make changes. You tweak the system prompt, change the model, and then you go again. And after a few rounds of this vibe testing, things start to spiral. Fixing one problem can cause another, and it becomes a game of whack-a-mole to try to get the agent to actually work. And a lot of the time, the truth is, you actually have no idea whether the changes that you're making actually are improving things or not. But eventually you get there, and you ship the agent to the client or to production, where real-world users will ask completely different questions and get completely different answers, some good and some bad. And this is the reality of building AI systems. Adding nodes to the canvas is the easy bit. Actually getting these systems to operate reliably and accurately can be quite tricky. In this video, I'm going to show you how the pros do it, and I'm going to give you the tools so that you can level up your game to create more accurate and reliable AI agents. And I think it's fair to say that the best AI engineers have what I would describe as an evaluation mindset. Before writing a single line of code, they create what is called a ground truth dataset. And this covers all of the various user intents and scenarios that the agent should be able to handle. And this part is key. We have not yet achieved AGI. So for our agents to work accurately and reliably, they need to be highly specialized. We need to define what is in scope and out of scope for these agents. And I hear you, this sounds like a lot of work. And in truth, there is more work up front to do it this way, but this will save you huge amounts of time and your sanity further on in the project. And importantly, it means that you can carry out changes to your system with confidence, with hard metrics telling you if things are going in the right direction or not. n8n has released its own evaluation system. However, for anything other than a single workflow, it can be quite expensive. If you're self-hosting, for example, you need a paid plan, so it's a minimum of $800 a month. Or if you're on n8n Cloud, you need at least the Pro plan, which is $60 a month. So instead, I took things into my own hands and I built a wrapper on DeepEval, which is one of the most popular open source AI evaluation frameworks on GitHub. This can do everything the n8n eval system can do and a huge amount more. And with the quick deployment to the likes of Render, you now have your very own evaluation system that you can trigger from n8n. And Render has a free tier, so you can test this out for free if you like. In this video, I'll dive into the concept of evaluating AI agents and systems, particularly through the lens of the DeepEval framework. I'll show you how to quickly spin up DeepEval on Render and ping it from n8n. I'll show you how you can tie it into an n8n workflow to get an evaluation result. And finally, I'll show you how I use this DeepEval server to create a fully fledged n8n DeepEval system. That includes a command center where you can generate synthetic test data from your documents, as well as controlling the execution of test runs, all reported on in Airtable. As usual, I've gone very deep into this topic, so if you like this level of detail, then make sure to hit that like button and subscribe to our channel for more deep n8n content. The DeepEval API wrapper that I created and some basic n8n flows are publicly available on our GitHub repository, so I'll leave a link in the description for that. But if you would like to get a head start and get access to our fully fledged n8n DeepEval system, which will be tied into our state-of-the-art RAG system, then check out the link in the description to our community, the AI Automators. Okay, let's get into it. To explain how to evaluate AI agents and systems, I'm going to borrow an analogy from Ido Pesach from Vercel's v0. The idea here is we have a basketball court and we have a player trying to throw a ball into the net. Simple, right? And in this analogy, green represents a shot made, whereas red represents a shot missed. And another consideration is distance. So the further the shot is, the harder it is to actually get. So these shots are essentially our test cases. So if we're building and evaluating an e-commerce chatbot, for example, an easy shot could be a question like, does your store deliver to Alaska? Whereas a harder shot maybe a question like, is the blue sweater that you had on the homepage yesterday still on sale? For this question, it's a quick lookup of what the delivery policy is, whereas this question would require quite a lot of reasoning and access to different backend tools to even figure out what sweater they're talking about. But the key thing is boundaries. While this is an unnecessarily difficult question, it is still in the domain. It is talking about the e-commerce store. Whereas here we have a shot made, but it's actually out of bounds. It's outside the boundary of the court. So from an evaluation perspective, it's essentially out of scope. It's a question like, who was the 29th president of the United States? It's green in the sense that the chatbot actually answered it correctly, but it's out of bounds because it's not relevant for an e-commerce chatbot, for example. Another consideration is the throw. So the dots on the court represent the test cases or the questions that you want to evaluate, whereas the throw is the actual pairing of the test case and its expected output, with the actual output that the system produced to see did it score. Ido in his presentation talks about two common mistakes people make with evals. The first is that there's no point spending too much time focusing on questions that are out of the domain or out of scope of the actual system. And the second is to avoid clustering your tests in one section of the court. You should have a broad, diverse range of tests across all of the features that the AI agent should be able to actually handle, so that way you're testing across the board. So this is what a good evals dataset would look like. You have lots of different types of questions from easy to hard. There's no unnecessary clustering. And with a visualization like this, you can see that there's a certain cluster of tests where this system is constantly failing. So what you see on screen may represent a single test run, and you can see that there are problems in the system answering here. So you may go away, make changes to your system prompt, make changes to the configuration of a vector store or the RAG retrieval, for example, run all of your tests again, and suddenly you might be flipping some of these tiles to green. And that way you can see that you're actually making progress and improving the accuracy of your system. So obviously this basketball court is quite an abstract visual. What do these data sets look like in reality? And at a very basic level, it's just a Google Sheet of questions and expected answers. And even if you're not interested in running evals on your system, I highly recommend that you take a step back before building your agent and jot down 20 to 30 questions that the agent should be able to answer. And then try to take a structured approach when you're building the system. So maybe you vibe test some questions to get it to a version 1, then run the full battery of tests, your 20 or 30 questions, and get a sense of the answers. If the accuracy isn't high enough, then start making changes. But again, don't do it willy-nilly. Do it in a systematic way to get to a version 2, and then run the tests again, and you'll see are you going in the right direction or not. This really is how the pros do it, and by the time you get to a version 7 or a version 8 of the system configuration or of the prompts, you'll get to a point where you can actually stand over the accuracy of the system. What you see on screen is the Google Sheet from n8n's eval system, and it's pretty basic, but you could take this approach with DeepEval as well. We took it a step further by creating a system in Airtable, where all of the test cases are represented along with their expected outputs. And the reason we did this is so that it can be more automated. We have test runs that could run every day, for example. We have the full execution log of tests and how each test actually performed in terms of an evaluation result, a score, and the reasoning why something failed. And we also have a full list of metrics that you want to actually support in your system. And this is probably the biggest benefit of having an evaluation system like this, is that you can carry out a battery of regression tests either when you're making changes to try to improve the system, or just run it every day. I'm using GPT-5 Mini for all of these tests, and I'm actually having great success with it, and it is pretty cheap. A test run of 20 to 30 test cases might only cost you 20 cents. And with GPT-5 Mini, there's reasoning built in, so it's ideal for a lot of these metrics. And why would you actually run it every day or every week, seeing as the configuration may be frozen when it's in production? And the reason is the model providers are constantly swapping out the models behind the scenes. For your agent, you may set GPT-5 as the LLM powering it, whereas in reality there are dated versions or builds behind the scenes. So you may have seen headlines about how certain models are getting stupider over time, and that is the reason why. So unless you freeze the actual specific version of the model in your agent may actually perform a lot worse in a week's time than it does today. And you would not know that unless you were carrying out regular evaluations in production. And this was another great example of the benefit of evals from Ido's presentation. Sarah Sachs from Notion posted about how they were able to roll out a new family of Anthropic models within 24 hours of them going live. And that was achieved through having an extensive evaluation framework. So they were essentially able to trigger a battery of tests against their system with the new model to see does it perform better or worse than the existing models. And they were able to then quickly deploy that to production. I've talked about the idea of creating a set of 20 or 30 questions that the agent should reasonably be able to answer. And there's a few ways that you can do this. Obviously, you can do it manually. There is another approach, which is you can generate synthetic test cases. So that's what we've built here in our DeepEval command center, where documents that are ingested into a knowledge base can also be sent into an LLM to generate test cases. So that's a good approach to create some decent draft test cases that can be refined and then enabled. But obviously this is synthetic. These aren't real customers or real users using the system, and they will invariably interact differently than how the AI thinks they will interact. So this is where you need some level of observability of your system when it's in production. So of course, pre-deployment, you can create your manual tests or your synthetic tests, but when your system is up and running, you should have some visibility on how users are interacting with the system. And that may be through something like the chat histories table if you're using the Postgres memory for your agent. So even just quickly eyeballing the conversations, you'll be able to get a sense of, are users actually succeeding with their interactions with the agent or not? You'll be able to then find edge cases that can inform the creation of new test cases and also assist you in fixing some of the problems that real world users are having so that you can flip those red tiles to green. I do highly recommend that there's an ongoing maintenance of your system to make sure it's evolving to meet the needs of the users. I'll be going through how I created these synthetic test cases in more detail later in the video. One of the most popular eval frameworks out there is a system called DeepEval, and it essentially can act as a unit test for specific components of your system, or you can use it to trigger black box end-to-end testing of your flows and agents. A key aspect of it is that it uses LLM as a judge. So the test case, along with the answer generated by your system, is sent to another LLM to actually determine whether it's scored or not. And importantly, DeepEval comes with 40 ready-to-use metrics that you can plug into your system to start evaluating straight away. And this covers everything from RAG to agents, multi-turn chatbots. There's even safety and multimodal metrics that you can use as well. And probably the most popular metric in DeepEval is GEval, which is a custom metric. So it uses chain of thought reasoning, and you outline the actual criteria for what passes or fails. So this is a great evaluation system. It has over 10,000 stars on GitHub, and one of the maintainers of DeepEval on Reddit 6 months ago mentioned that the DeepEval cloud platform carries out 600,000 evaluations every day. The difficulty with evaluating your n8n agents using DeepEval is that it's a Python application, so it can't run on the n8n server, you need to host it elsewhere. And it doesn't come with the server or a REST API layer out of the box, which is why I actually built my own and shared in the link in the description below. So in a few minutes, I'll go through that wrapper that I created and how to actually spin it up on a server so you can start testing your n8n application straight away. If you have any experience in building AI agents in n8n, you'll know that it can be tricky to track down why an agent produces a certain answer. And there's some really interesting metrics in DeepEval to help you track down the source of the problem. And the first one worth discussing is the difference between what is an hallucination versus what is a faithfulness problem. So if you have a RAG system and you're returning or retrieving chunks from a knowledge base, the LLM is going to base its response on those chunks. So if the agent is spitting out what looks like an incorrect answer, you may assume the AI is hallucinating, but it actually might be a faithfulness problem. It's trusting what it's getting back from the vector store, but the problem may actually be that the data in the vector store is incorrect, or it was a problem with chunking so that some of the information was actually cut off. So that's essentially what this faithfulness metric and this faithfulness test is. It evaluates whether the actual output factually aligns with the context of what was retrieved. Another good one is answer relevancy. So this evaluates how relevant the actual output of your application is compared to the provided input. So if you're getting a totally irrelevant answer to the question that was asked, this will fail. Contextual relevancy is another great one. It evaluates the overall relevance of the information presented in the retrieved context for a given question. So DeepEval is a great evaluation framework to test your AI systems. The problem is there's no way to actually hit it via API. It's a Python application, and they give lots of sample code on how you can tie it in to your Python agents, but there's no easy approach to actually trigger this remotely. DeepEval is run by Confident AI, and they do have a cloud platform, but to actually run evaluations directly on their cloud platform, you need at least the premium plan, which is $80 per user per month. They have a free and a starter plan, but those require you to actually integrate using their Python library, which obviously we can't do with n8n. There's very limited functionality that you can achieve using the Python code node in n8n. So to be able to trigger DeepEval from n8n, I created an API wrapper for the framework. I've published this on our GitHub repo. I'll leave a link for it in the description below. But it's essentially a REST API wrapper with authentication where you can use HTTP nodes in n8n to actually ping the service to evaluate different test cases. I've also included quick deployment instructions on how you can actually quickly test this out on render, even on their free plan as well. Now this is an early version. I've tested out a lot of the core metrics and features, but there's a huge amount of functionality in DeepEval. So if there's any experienced Python developers that are interested in getting involved in this project, definitely reach out and let me know. But the actual deployment setup on Render is super fast, so let's go through it. So go to render.com and you can create a free account. And once you're logged in, click on Add New and then choose Web Service. And then go to Public Git Repo and then paste in the link to the repo that's in the description below and click Connect. And then in terms of the instance type, you can absolutely test this out on the free plan. The problem is these free instances spin down after 15 minutes, and then you need to actually ping them again to get them back up and running. So this will cause errors in n8n if the actual instance goes to sleep. So the starter is probably a better choice, but I'll set it up as free for the moment. And then within the GitHub repo, we have different environmental variables that you'll need to set. So the OpenAI API key is the first one because this is LLM as a judge within DeepEval. So you can just go to the OpenAI playground to get a new key and drop it in here in the value. So that's done. And then you can add another environmental variable, and this is API keys. Now it accepts actually more than one comma separated, but we'll just set a single one. And I do recommend that you set something pretty secure here. So I'll just create a long password on LastPass, and that's pasted in there. And that's pretty much it. Just click Deploy Web Service. And then it starts cloning from the project, building out the instance. And after a few minutes, our DeepEval server is up and running. As you can see, it's available at your primary URL here. And if you click it, you'll get this message. But if you go to /docs, then the REST API wrapper docs load up. So there's lots of different endpoints here that you can hit. The main one that I use is this evaluation endpoint. And that's what we're going to test now. So if you go back to GitHub, I have an example usage, which is a curl request. So let's copy this out. And if we go into n8n and create a new workflow, we'll just do a manual trigger, a HTTP request. We'll import this curl. So we'll just paste it in here, click import. And then for the URL, you need to now drop in your URL. So that's what I have here. And then for authentication, you need to drop in your XAPI key. Now, again, it's best practice to actually set this under authentication using a generic credential type and a header auth. But for the moment, I'll just drop it in here. And then you can see it's sending this body. So now all we need to do is click execute step. And it's just pinged the new server that we've spun up on Render with this test case, which is an answer relevancy metric. It's passed an input, which is what are the benefits of renewable energy. The actual output that we're simulating here is I enjoy pizza, so obviously not relevant. And you can see that this answer relevancy test has failed. The score is 0 because the actual output only discusses topics about pizza, not about renewable energy. So there you go. That is how you can quickly deploy DeepEval to a server and hit it with n8n. So how do we tie these metrics into n8n to carry out evaluations? I've created a full library of custom nodes in n8n that trigger the various DeepEval metrics. And each metric has example data to show both passes and fails. This metric library that I've created covers the custom metrics like geval, the RAG metrics like faithfulness or contextual relevancy or retrieval, the safety metrics like bias, toxicity, role violation, PII leakage, and agentic metrics which are really important, like tool correctness, did it call the right tool? Argument correctness, did it pass the right arguments? Task completion, did the agent achieve what it needed to achieve? And then the multi-turn chat metrics, like role adherence, turn relevancy, knowledge retention. So there really are some amazing out-of-the-box metrics that you can use with DeepEval. And then for everything else, you can create your custom metrics with geval. So if we look at the geval metric, for example, which is by far the most popular DeepEval metric that's used. If we click into it, we can see that this test case, the input is explain the benefits of renewable energy. The actual output is very relevant to that and very much matches the expected output as set within the test case. And then this geval metric is a custom metric. So you can decide how the LLM as a judge reasons over the criteria to determine whether it was a success or not. So here we're saying that this is the content quality custom metric. Evaluate the response based on accuracy, completeness, and clarity and depth of information provided about renewable energy. So you can get hyper specific with these custom metrics, and that's why they're so popular. So if I just run this, for example, that's going to our DeepEval wrapper or our DeepEval server, and it's generating a result. And you can see we've run geval. It has given it a score of 1. The threshold for it to succeed was anything over 0.7. And the reason is the actual output is factually accurate and covers all key points from the expected output. Now this one actually used GPT 4.1, but I do recommend GPT 5 mini. And then you have these verbose logs that explains how it reached its decision, which is really good. And now if I trigger the node that should produce a fail, and if we click into it, here we're saying explain the water cycle. The expected output is the water cycle involves evaporation, condensation, precipitation, etc. And the actual output is water goes up and down. Sometimes it's hot, sometimes it's cold. So this one failed this custom metric because even though it is actually accurate, you can see the reason it gave was it lacks scientific accuracy, omits terminology, so it doesn't really align with the expected output. So that has not succeeded. So the GEval metric is brilliant because you can use it for any specific criteria that you want to test against. And they have an adapted version of GEval specifically for multi-turn conversations. So you can pass in the full conversation history with the agent to determine whether it aligns with whatever custom criteria that you have. So if I execute this one, for example, and let's have a look at it, there's the full conversation history. And our custom criteria here is to evaluate whether the assistant was providing clear, patient explanations to a student understanding the maths concept. And it did a great job and it passed. Whereas the negative of that has failed. The assistant's role is correctly set, but the content fails to provide clear or accurate explanations. So there's a version of this library in the GitHub repo linked in the description below that contains some of the metrics that you can actually tie in. The full library, along with our n8n DeepEval system, is available in our community, so check out the link in the description for that. So okay, we now know how we can trigger our DeepEval server using a custom HTTP node in n8n. So how do we tie it into our AI agent or our workflow to actually trigger these tests? So there are 3 different layers that you need to consider. The first one is the Google Sheet. Where do you actually have your test cases defined? So in our case, it's an Airtable base. So once you have your test cases created, you need a way to execute a test run. And we've done that here in our DeepEval command center, but it's essentially just a workflow where you can just trigger a manual run, which can fetch the test cases, in this case from Airtable, but you could do it from Google Sheets. And for each of those test cases, it triggers a run of the workflow that you're evaluating. And all we're doing here then is we're just aggregating all of the results and updating the test run to show at a global level how well the test run succeeded or failed. And the data that it's passing to the workflow that it's testing, it's passing the test case input or the query, the expected output, any expected tools that are to be called, the various metrics like faithfulness or toxicity or a custom GEval metric that you want to evaluate against this test case is passed in as well, along with a couple of IDs. And you can see that this is an execute a sub workflow node. So then at the base level, you have the workflow that you're evaluating, and this would normally have a standard trigger that end users would interact with this agent or the system, but it also now needs an additional trigger that can fire when you're running a full test run. So that's what's here, and that's what's mapped in the various fields. So here I can see the question is, can I get a custom embroidered jacket with a company logo? The expected output is this, and we're running 2 different metrics. Now these are the IDs of the metrics in Airtable. Then we essentially set up that data. We're just creating a random session ID. This is the chat input, and we're setting an action because we need to replicate the inputs from this trigger in this node because the agent can then process the values from either stream. So let me run this now, and the agent is processing the test data. We have an if node to check, are we in an evaluating state, or is this just an end user asking a question? And if it's an end user asking a question, you just do nothing and return the output. But because we are evaluating here, what we want to do then is for each of the metrics that we want to test, we fetch them from Airtable. We create the test run in Airtable as well in our execution log. And this is why Airtable is better than Google Sheets really for this. We have a custom code node to set up these metrics so that it's compatible with the REST API within the DeepEval server. And then we trigger the actual calls to the wrapper that we've deployed to render. And we're passing in the full body. So you can see, can I get my company logo embroidered in the jacket? The actual output that we got from the agent versus the expected output. We're also sending in the retrieved context from the vector store, and we're passing in the metrics that we're actually going to test against. So this time it's answer relevancy, but this will run multiple times for multiple metrics, as you can see there, 2 items, and we update the log. And now if we go into our execution log, you can see that that completed, both of them passed, and the evaluation cost was 1 US cent each. And you get a full rationale then as to why this actually passed. And this is really interesting because the different metrics have different ways to evaluate whether something has passed or not. So for faithfulness, for example, what it does is it extracts out the truths that are in the retrieved context, and then it extracts out the claims that are in the actual output, and then it goes through each one of those and makes a verdict as to whether each claim is actually grounded in the extracted truth from the retrieved context. And if it says IDK, it means I don't know. If it says yes, it means it's fully backed up. And if it says no, it's a fail. So then based off the threshold, it'll decide whether that has succeeded or not. So here it has passed because the various claims have actually been grounded in the retrieved context if they're in the context. And while it may look complicated, this idea of an evals trigger, checking to see if you're evaluating and then executing them, it's exactly the same with the n8n eval system. So with n8n, you still have your evals trigger, you still check to see are you evaluating, and you still execute the actual metrics and save them to the sheet. The difference with n8n is you don't need this type of workflow to trigger the test run. Instead, you actually use the evaluations tab and click run test on the top right. And they obviously have their reporting inline in n8n versus what we would have here in Airtable or what you would have in a Google Sheet. But of course, you have those limitations I talked about, that you can only have a single evaluation workflow without needing to upgrade to a bigger package, which is quite expensive if you're self-hosting. So this DIY approach of building your own eval system using the DeepEval's wrapper I created is a lot cheaper and a lot more flexible than what n8n offer out of the box. This is how we generate synthetic test cases based off the documents that you upload to your RAG system. So here we have a standard Google Drive trigger, which is going to pick up a file that's in a set folder on Google Drive. Here I've dropped in a JSON file that contains all of the products in this store. So the idea here is we're going to download that file from Google Drive, extract out all of that JSON, and then send it to an AI agent, a long context window AI agent, and get it to output the test cases. And a quick look at the system prompt for this agent. We're essentially saying that they are an expert at creating evaluation datasets for AI systems. We're providing a document and need it to generate high quality test cases. But importantly, we're saying, put yourself in the shoes of a customer of an e-commerce store and craft the test cases from that perspective, because you don't want them to be overly formal. And then for each test case, we're asking it to generate the input question or the query, the expected output based off what's in the document, the context that supports that response, and then any recommended metrics that could be used to actually evaluate that question. And we list then the available metrics to choose from. And then also importantly, we're providing question types. So there are different types of questions that we will want to test: edge cases, boundaries, standard questions. And then we provide the JSON output, and that essentially is what DeepEval requires when we're actually triggering the evals on their system. And then from there, we save all of those test cases that are generated by Anthropic's Claude Sonnet 4 here to the Airtable that we have created. So even if you weren't using our DeepEval system, you could create something similar to this yourself and save these test cases to a Google Sheet, for example. So let's quickly run this. I'll trigger the workflow, and it's downloading the file, extracting the JSON, sending it to the AI agent to generate the test cases, and that has succeeded. As you can see, it's just streaming through now. And we have questions like, what's the price of the Joust duffel bag? Which bags are currently out of stock? I have a small wrist. Do you have any watches that would fit me? So this is a decent starting point to help you evaluate your system, because you also get the expected output. The Joust duffel bag is priced at $34. There are several watches designed for small wrists because the actual dimensions were in the product description of those products. So that's the benefit of using long context models to load up a full document and get it to output synthetic test cases. It's not going to be perfect though. You do definitely need to review the types of queries and the expected output just to sanity check that it is actually correct. So we'll be building this synthetic test case generation into our state-of-the-art RAG system that you may have seen already on this channel. So as people ingest documents into their RAG agent, we'll be able to spit out draft test cases that you'll be able to verify and evaluate your chatbot off. I hope you enjoyed this video. If you'd like to test it out, links to the DeepEval wrapper are in the description below. And if you'd like to get a head start with our n8n DeepEval system, then the link to the community is also in the description. Thanks so much for watching, and I'll see you in the next one.